Just a quick bit on spectroscopy of aromatic compounds. The IR of aromatic compounds, I mentioned earlier in the IR chapter about how we can look down in the fingerprint region to tell a bit about substitution patterns. That's just something you can look up if it comes up. That may be a case in one of the experiments that we're doing. I'm not sure, but that's just something you need to look up. The other things to look at are the sp2 CHs that are above 3000. Okay, gives you an indication that there's some sort of unsaturation happening. CC bonds, 15 and 1600. One thing the book doesn't mention that's actually a pretty good giveaway of an aromatic system are all these little bumps between 1600 and 2000. Okay? So you'll usually see like 4 or 3 or so little bumps around where the carbonyl region, right, the C double bond O region would normally be. But if you see something like that, all those little things just below 20,000 and above 1600, that's usually a pretty good giveaway of an aromatic system. For NMR, it's actually very interesting because remember, NMR has a magnetic field and it makes measurements based on how different protons or different nuclei come into resonance with that magnetic field. Having an aromatic ring, when it's exposed to that magnetic field, the electrons will circulate around that aromatic ring. So if you've taken physics, you know about the right-hand rule, how an electric current will be induced from a magnetic field. If the supplied magnetic field is my thumb, the induced current around the ring is like my right hand closing, going sort of counterclockwise around it as if we're looking from the top. So, well, when we have an induced ring current, we induce a new magnetic field going sort of outside of the ring that way. So the consequence of that is that it ends up de-shielding those hydrogens. It makes those hydrogens appear like they've absorbed more magnetic field than they actually have. So the main consequence of that, the thing you need to know about NMR, is that the hydrogens on a benzene ring will appear between 7 and 8 ppm. Very characteristic region for aromatic hydrogens. And it's really pretty specifically because of that ring current. Normal sp2CHs, are in the 4 to 6 region, okay, where let's call those non-aromatic. But around an aromatic ring, because of all this weird ring current stuff, that's what pushes the resonances downfield to the left between 7 and 8. So we'll be seeing those quite a bit in the lab as we're interpreting some of those NMR spectra. So that's what we need to know about aromatic systems. Next up are reactions of aromatic compounds.